The countdown clock goes so quick now. We used to have it at 5 minutes. Now we're like running around the last 60 seconds. Welcome everybody to NVIDIA Omniverse live stream. A very special show today. As you can see, we have some great guests joining us. We are going to dive into building OpenUSD based retail digital twins, and we'll explore what that means. And we have a very special guest with Mode Maison here. We have two folks, Mode Maison team, and we're also joined by a member of the Inception team, which is NVIDIA's startup program. We're going to dive into all of that in just a few minutes. Get your questions ready or start posting anything. If you know them now, just feel free to post there in the chat. Big thanks to Jonathan Finger, who helped put this together from the Mode Maison team also. He was very great to work with throughout this process. And Amelia is on the community team. It's helping us in the chat. So we are going to dive in just a couple minutes. Few short announcements. One, we have the OpenUSD training labs are now available on demand. These are the labs that happened at GTC just several weeks ago. So feel free to access them through the link that Amelia is going to post in the chat. Super exciting content and learnings there. So we hope everyone takes full advantage of those training labs, which are now live. As well as all the other GTC sessions are live. So you can, even if you did not register for GTC for some reason, you forgot, but the sessions are now available for everybody. Amelia will also post a link for that in the chat. There's so many great sessions available. So take full advantage of those free sessions. They're ungated and totally free for you to watch. Give us your feedback or questions on the Omniverse Discord if you have any. That's discord.gg/NVIDIA Omniverse. And we have a channel specific to GTC called GTC. So feel free to post any questions you have on the content there. And I see Amelia's already there posting the links. Fantastic. And then we have a great ITO or Into the Omniverse article that just came out, focused on Siemens, which was actually a guest on the recent live stream, and also was at GTC at a fantastic booth with my colleague. Richard was one of the people presenting there. Showing this shipyard scene actually in real time, which was pretty amazing. Siemens is obviously doing some fantastic things. If you follow the NVIDIA Omniverse page on LinkedIn, you've actually seen some great content in the last few days due to a conference that's in progress right now in Europe. So check out that NVIDIA Omniverse LinkedIn page to get the latest updates from there. And also be sure to read that Into the Omniverse article. And then last, but certainly not least, we're talking about OpenUSD today. And what better time to explore OpenUSD if you haven't than now? We are really excited to promote and share and celebrate everybody's journey with OpenUSD, as there's, even if you're just discovering it now or you're a veteran user of OpenUSD, connecting different apps and workflows together. We have a challenge called the hashtag OpenUSD challenge. And all that means, basically, we'll post a link in the chat, but all that means is if you are willing to share any pieces of your journey working with OpenUSD on social media, use that hashtag. We'll all be able to see it and celebrate it, and we'll be able to promote it as well. I'm really looking forward personally to seeing what people are fooling around with OpenUSD on their own projects. And we have a channel specifically for Community Challenge also on the Discord server, just called Community Challenges. So with that, I would love to get started and dive into our topic for today. As I mentioned, we have some very special guests today. Let's do a round of introductions. Everybody knows me. Let me get everybody's name tag on here. Let's start with Jakub right next to me. How you doing?
Hey, hello everybody. I'm doing great. Thanks, Admar.
So tell me a little bit about your background. So you're with Mode Maison. You're the CTO, correct?
Yeah, that's correct. And I actually started. It was way back as a 3D artist, as many people discovering the wonderful tools, and then I actually dedicated my intersection of technology and art to Archviz. So I went technical but more artistic. I worked as a 3D art director for Premiere residential developments like Four Seasons, etc. But then, I mean, the artistic part of me, it just prevailed. I did a book. It was called Computer Generated Images, which it was that I worked a year on, and then, pivoted when I felt like I was chasing the photorealism down to its bone. I went to join Mode Maison 6 years ago, and then basically went on this really, really deep rabbit hole of trying to, build the ecosystem of doing the most faithful representation of surface digital twins that, was my endeavor, basically, that I got on.
That's amazing. So we're really happy to have you here because we have a lot of developers that are watching the live stream, and I think they would love to learn about how, from a technical standpoint, you started to leverage OpenUSD, or also even why you started leveraging OpenUSD. And then I also know, we'll get more into this in a few minutes, that you have major plans in the future for leveraging OpenUSD as you have been realizing the benefits. And to that point, I'm very happy to introduce Stephen Gay. How you doing, Stephen?
Hey guys, how's it going? Thanks for having us.
Yeah, of course. It's an honor to have you here. And Stephen, you founded Mode Maison, right?
I did a little over 6 years ago. Yeah.
So
and our co-founders.
So 6 years. So that's great. And you have two co-founders, you said?
It's Jakob and I co-founded the company.
Oh, great.
Yes.
Okay, cool. Oh, you co-founders. Great. And so tell us about kind of your background a little bit, and then we'll get into Mode Maison, why you created it.
Yeah, sounds great. So I have a very non-traditional background within the CG space. I kind of joke that I used to be able to barely turn my phone on. So I come at everything from a very, very different perspective. A bit of background on me was I before Mode Maison, I was actually in the fashion space. So I was pulled out of school a little bit early and became the youngest concept designer of Ralph Lauren Purple Label. So it was really cool because, doing meetings with Ralph himself and kind of design the concepts for the global company. So a very, very creative position. I don't know how I got the job, but it was an incredible experience. And that kind of got me, we kind of say we were building movies, and then we kind of designed the clothes within these concepts. And it really could have been any product. It could have been the set or like the interiors. It could have been the clothing. We were just kind of building these dream worlds. And then when it was actually IKEA that I saw was doing CG. And at that point, I'd never really expected, I didn't think the technology existed basically to be able to push the realism to the levels that we need today. And so started really digging into it, and kind of here we are now, 6 years later, spiraled out of control basically in terms of the majority of our team are scientists in the back end. And so I've gotten a very, very quick and expedited, I guess, education in this space.
Well, that's awesome. Super valuable background, because this follows up a really great blog that was just published. Amelia will post that in the chat so everybody can check it out. But this gives nice background also on Stephen's journey. And we talked about this a second before the show, but I never didn't get the answer yet. Tell me a little bit about the name Mode Maison. It's a really cool name. How'd you come up with it?
Yeah, so this some people love it and some people hate it. Actually, full transparency, good. I'm on your boat. So I don't think I know it's not actually grammatically correct in the traditional sense. So Mode Maison, we started out as a multi-brand retail platform for the luxury home goods space. So very, you could think of basically Farfetch meets Pixar. It's kind of like what we were doing. So in the spirit of that, and kind of like taking my background in fashion, so a la mode, or being like kind of fashionable, and then maison meaning house in French, and then just kind of stuck them together. People get confused now because of we're licensing a lot of the technology out to some very large companies. They're like, what in the world is the Mode Maison name? So we kind of say Mode Maison Labs is the technology engine, and that's where we do all the licensing of the technology. And then Mode Maison is the kind of the platform that is soon to go live.
That is awesome. That is so great to know. I'm curious. So just really quick before we introduce our next guest, how did you guys end up kind of meeting each other and working together? Because you've got all these ideas, and then Jakob, I'm sure just knowing, I know Stephen a little while, knowing how his brain works. How did you keep up with everything and kind of just?
I don't. It's impossible.
So actually, it's a funny story because Jakob and I always kind of like tell the story about Jakob and I started, and initially I wrote like love letters, basically. I would write him these super long love letters, and he's like, all right, this guy's a little bit of a psycho. I guess I'll respond back. Finally got a response back, and I was like, Jakob, I'm coming to Slovakia. I'm going to spend 3 weeks there, and we're just going to become best friends, basically. And we've been tied together at the hip ever since.
That is
fine,
amazing.
yeah.
That's inspiring too. And I wanted to bring that up because our next guest actually is from NVIDIA's startup program, Inception. And congratulations. I think you guys are now part of Inception, I hear.
Yeah, we're super excited. Thank you.
So that's fantastic. Les, thank you so much for joining us.
Absolutely. It's a pleasure to be here. And the Mode Maison team is near and dear to my heart because before I was at NVIDIA, I was founder of a startup called Lexset that built an AI for interior design for Herman Miller. Lexset ended up pivoting to synthetic data, but still the cross section between interior design and technology is something that I'm all about. My role here at NVIDIA is I am the Inception Partner Manager for manufacturing, robotics, and autonomous vehicles. And what we do in the Inception program is we really offer 4 areas of benefits. First, I should say that it's pretty massive. We have close to 20,000 startups in the program. So if you're a legitimate startup, as long as you're not a crypto startup, you are welcome to be a part of it. You get a few things for joining. Number one, you get discounts on NVIDIA hardware, about a 30% discount across the board on most things. Number two, you get $100,000 or so of cloud credits between AWS and GCP. Number three, you get access to things like our Deep Learning Institute for learning some of our various SDKs and APIs, as well as NGC, which is our catalog of toolkits, APIs, and SDKs, all very, very helpful for building AI-based applications. Then we have go-to-market activities we'd like to do with startups, like we're doing right at this very moment. And also we have something called the NVIDIA Capital Connect, which is a program where we match make between VCs and startups.
And I think that, so those are amazing benefits, many of them. I also know the startup partners, there was a great Inception party at GTC, a lot of fun. I met a lot of great people from startups. But you know, it's amazing that it's a free service available. There's really no reason if you're using NVIDIA technology not to get in touch with the Inception team or learn how it can help you. So really glad to have you here, Les. Feel free to jump in at any point. You've been working with this team very closely, and it'd be great to have your perspective. We actually have one question here that kind of relates to startups from Zia. So really briefly, because I know we want to get into the meat here, and there's a lot to go through. But he's curious about, this is for Steven, I guess, the failed retail trip that inspired a revelation in a company. I guess, yeah, we didn't really go into that in the blog, but do you want to?
Yeah, okay? So I was about to say, oh boy, it's a long story, but I'll try to condense it. So the home goods space is very, very particular. We kind of call it the last bastion of luxury to go online. And that's for a whole bunch of different reasons. So when I was at Ralph Lauren, I was trying to buy a sofa, asked some friends who were interior designers and architects for basically a couple of different showrooms that I go to in New York that they think I would like. And so I went to the first showroom that they suggested. I saw a sofa I loved and basically was trying to hand a credit card to a sales associate and just kind of asked about pricing and was asked for my ASID number or trade association ID number. So they're like affiliated, I guess, organizations within the architecture space. And so I'm neither an architect nor an interior designer. And when they learned that, I was soon very quickly escorted out of the showroom and was told I couldn't purchase a sofa, which was crazy. I thought it was insane. So I ended up going to the second showroom. Long story short, I went to like 10 different showrooms and wasn't able to buy a sofa. So I was like, all right, there's an issue here. When we started digging into the problem, there's a whole bunch of reasons why, but just very, very quickly, I think it might illuminate why we kind of do a lot of the stuff we do. When you in fashion, so again, my background being fashion, you might have a shirt that comes in a couple different SKUs, so like red, white, and blue, and everything is already pre-made. In home goods, and especially luxury home goods, everything's made to order. And then on top of that, you might not have 3 SKUs. We're talking on average, a product might have 2,500 SKUs. So you take like 17 leathers, 45 linens, 3 woods, 5 metals. You start to multiply that up, and it becomes an astronomical number. And then on top of that, even more so, then you have to create this beautiful kind of immersive experience where designers and interior and architects and people like all of us can actually purchase the product and want to purchase the product because of just the category and the price point with these products. So you have a product that comes in an infinite amount of SKUs. It doesn't exist because everything's made to order. And then you have to make it and put it in a place that's more beautiful than imaginable across millions and millions of products. And it becomes, it's it's an impossible solve if you're trying to do it in the real world. And then hence kind of what we've done today is digitize that PLM basically.
That's amazing. I think it's really helpful to hear that actually, and hopefully inspiring to others out there working on their startups and ideas. You never know what's going to be right around the corner for yourself. So keep your head held high. I see also another member from the Inception, one of the members of Inception or recipient is in the chat. So welcome here. All right, so let's dive into what Mode Maison is. So it's fair to say that you guys, are definitely building a digitized generative retail model for the future. You're working with lots of great companies, and you have an infrastructure that you call DigitalCore, which is basically behind all of this. Can you go into a little bit more about the current state of affairs for retail and why you think this DigitalCore and how this is going to be beneficial for the industry?
Yeah, I give a quick kind of synopsis on that. I don't want to hog too much of this, but Jakob, just cut me off obviously whenever. The way you can think of DigitalCore is it's basically a framework for thinking. So DigitalCore to us, it essentially means a digitized way, or like digitizing all of your systems. So what we mean by that specifically is that if you digitize an asset at its core in a single source of truth method, that can essentially work across the entire PLM or product lifecycle management system. So think everything from design and production all the way to the actual experience level. So if you create an asset that can be used across the entire chain, and if you base it in real world physics, essentially, what that does, it unlocks an entirely new world of commerce, and almost gives you goosebumps to think about what that can enable. So DigitalCore, that framework, is basically tackling digitization in a basically it's more of a first principles approach to digitizing. And so once you have that basically infrastructure set up, what you can do with that is I mean, pretty much transform the way we do retail. Just because if everything's digitized, then what that means is you can start to actually enable kind of a generative retail model of the future. And so, Edmar, Les, Jakob, if everybody goes onto the site or any site, basically, by adding this generative component to all these digital assets and digital environments, each one of us could have an entirely different experience whenever you go onto a website and purchase a product. And then taking that a step further, it's not too crazy to think there's a world in the future where actually every single product can be designed and developed specifically for you and only you in real time.
And then if I could interject a little bit into that, because I believe it's important to understand the difference between like how data or how materials are, let's say, measured or harvested nowadays, and what the DigitalCore actually proposes. Because it proposes to standardize what actually to measure and actually store that information. So, for example, the today real-time models, etc., they can perform only and take you only so far, but super nearby, there's going to be these new models that are going to, of course, like fulfill the full belief of digital twins. So this is setting the foundation of what all you need to harvest and actually store in order to have, the digital twin in its essence. And once that is harvested, you pretty much have all the information needed to get to where we're heading.
So there's that DigitalCore framework, and then there's the DigitalCore Consortium, which is a different piece. I mean, they're one and the same. They kind of go hand in hand. But again, we're really setting up, and we can dive into the TMAC in a bit, the scanning technology we've developed. But it's really, right now, we just don't think that the infrastructure set up to create, for instance, I'll be very specific, like digital materials, for instance. OpenUSD does an incredible job of enabling our team basically to have a much more single source of truth basically workflow. So we know, so it's basically it's more interoperable, I guess, so to speak. But we, the TMAC, we before we developed it, we thought that there needed to be a necessary, it was critical to basically build a framework to create a material objectively, to then be able to train on top of those going forward. And so we're super excited about obviously OpenUSD because it enables that interoperability, and it enables this future where we can actually train models based on a lot of data.
Yeah, that's amazing. And so you brought up the TMAC. I have a quick video so everyone can kind of really picture what the TMAC looks like. It's a hardware device, right? And it's basically very capable of capturing very, very detailed data on whatever material can basically, and it looks like it's pretty big, so it can probably capture anything you need for any kind of retail, but let me see. Let's play this so everyone kind of visualize this and take a look at the TMAC device we're referring to.
Hey, Jakob, do you want to walk through what this is, what everybody's seeing?
Yeah. So meanwhile, the video is playing. It's a cross-porous photometric stereo scanning system, and in the current version, let's say it's V1, the data is a little bit sparse. Let's say in an upcoming version, there's going to be many more angles, many more data harvested, and what it's doing is that in this current version, it basically extracts and creates a digital twin within PBR, within OpenUSD, within the MDL. Right, so that's where we're leveraging what's possible today, and basically dividing the real surface and making the digital twin.
And I think I have so Stephen, I have a few videos here, and one of these videos, actually, they'll probably show the output from the TMAC. That's it looks like.
Yes, I guess it'd probably be good to show the kind of the outputs, and so. Again, when you think about what the TMAC is enabling, so we're doing a lot of model training on top of these materials. And so we're also this is a behind the scenes video of a BTF scan, so bidirectional texture function. And so what we're doing is actually putting a material in both the TMAC and a BTF scanner at a research institution, and actually starting to be able to learn if there's any, basically, if we can extrapolate different data points from both. So then we can actually embed a lot of these properties in basically just a TMAC output down the road. So there's a lot of really cool things we're doing on the AI front and the machine learning front behind the scenes. And so, ultimately, Edmar, the thing that we're working towards is capturing enough data basically to be able to unlock this capability where you can actually take your phone and actually take a picture of any fabric. And then ultimately, and again, this is very rose glasses kind of outlook on the future, but all indications are pointing to being able to basically take a picture of a fabric on your phone and then recreating that fabric entirely parametrically with all the actual simulated properties embedded into it. And so right now, I think it's important actually to mention this. Right now, the framework for digitization across materials, again, it's an entirely subjective process. And so the whole reason behind the TMAC is because we had a lot of really incredible material artists on our team. But then there comes a point, and it's been a chokehold of how do we scale beyond that? And if Joe created some material, 5 years ago, well, how did Joe create that material? And then it just becomes a nightmare situation for retailers specifically. So having that objective data set really enables us to do a lot of cool stuff.
Yeah, definitely. And I'd like to also dive into the interoperability portion of this, because that's kind of, I guess, where you recognize that OpenUSD would be a powerful tech to embrace. Can you talk a little bit about, maybe this is more for Jakob, would it be possible to go through kind of how you started to enable OpenUSD and kind of what it's done for your workflows? What was the kind of first steps there?
Mm-hmm. Well, and I'm gonna, if that's fine, entail it kind of together with the software that we have for TMAC, because that is integral parts to the whole pipeline. As the capture that's coming from the current TMAC need to be seamlessly tiled, and also it needs to be extended, let's say. So we have a whole suite that we basically in a couple of minutes process the materials. The TMAC is calibrated within all the maps in a way that you can preview and see everything up front as how it looks. And then we've been also, of course, looking for legs and to our body. So, as throughout the formats that are available and how everything is going, the OpenUSD offers the most flexibility to actually be open enough and extensible enough to also be ready for all the upcoming metadata, like physical measurements, BTF dense measurements, spectral measurements, etc. So we wanted to find the right channel of where to save this and be ready for what's coming next. And of course, the OpenUSD offers all of that and interoperability, because in the end, when you take currently PBR maps and you're working, let's say, on a commercial project, you need to render it. You need to show it somewhere and somehow. So animation team is using Cinema 4D. The rendering team is using Corona. The other team might be using something else. Completely, disrupts how it looks altogether. So we've been looking for how to save it and how to make it interoperable for everybody. thus, yeah, that's what we've leaned into, and OpenUSD is the #1 format that basically our software is going to be capable to save at, and we think that it's going to be also within the Omniverse, which is to us like a lab to make all the tests and make everything grow. Is the only kind of bet for let's say the length of where we want to walk.
It's important to reiterate. So the TMAC, to date, we've been putting on factory floors with some of the largest retailers and brands and manufacturers across the world, and we've obviously been using it internally as well. But we're super excited because next week we're going to be actually opening it up to the public. So we're going to have a public beta release, so both the software and the hardware, and we're super excited about that. And also, another really incredible piece here is that actually it's going to be the first native export directly to OpenUSD. So there's going to be direct integration with Omniverse. So
that's awesome.
That enabled that. A lot of the brands we're working with are super excited as well. I know Edmar, we've talked to one of them in the past, and that's really a critical piece for them because the company we're talking about in this instance, they are one of the large retail companies. They kind of parent companies. Within that company, they have 160 brands, so 160 companies within them, and they have factories all over the world. And so the interoperability issue, not only do they have to have hyper fidelity, like 1-to-1 fidelity when it comes to the actual realism and the physics behind it, but the interoperability piece, like just from I guess a management perspective, it's so critical. And so OpenUSD and Omniverse is enabling all that.
Yeah, that's amazing. You can just imagine the time is saved in recreating and redoing steps when previously things were very siloed from each other when you have such a complicated workflow. We have a good question here, actually. Would you scan all the materials for a given piece of furniture? So I guess in this case, 17 leathers, 45 linens, 3 woods. How long does that scanning process take? So this is kind of a very, I guess, literal question on the process, but would you?
Yeah, we would.
Exactly.
Yeah.
It's funny. So I'm picking up on it's Jakob. I guess, do you want to go through on how we scan a piece of furniture and how we?
Yeah, I can do it. Well, actually, 5 years ago, and this is I guess a very good question for me because 5 years ago I did the scanning by hand myself, and I scanned like 100 materials. So I did a tape on a floor. I did the web. I did like 16 posts. I had like a light with polarization filter that I could rotate by hand, and I had like little markings, and I did like stand, take a picture, rotate the filter, take a second picture. So so it's been insane, and still like we started with the same as basically what ties us together with Steven is really the let's say fanatism about quality as well. So that's what we're vibing on a lot, and we've started even without the tools at the time, and we're still doing it the same way. Although before it took me like 15 minutes to scan a piece, now it takes 1 minute to scan a piece in TMAC. So yeah, and we're trying, of course, 17 letters. That's a lot when you're talking about hides, because it's not really easy to get a full hide times 7 teams from companies. But we're like pushing on that front as much as possible, and we've scanned full cow hides, like 3-4 meters big ones in pieces. And of course linens. That's fine. Like you can kind of easily get a roll of linen. That's not so bad. And wood again, that's a little bit more tough. But when you battle a lot, like that's pretty much the only way to make this scalable. But not to ship it to us, but actually to, as Steven said, to put TMACs on the floors to the manufacturers themselves, which is something we're pushing a lot because logistically this is becoming a problem. But I would think we've been finding this very bravely, and
it's just better. So like whenever you have TMACs on factory floor on like basically at a brand's premise, in some cases, if you just take the fabric directly off the mill and put it in the TMAC, somebody as non-technical as me can use it. So like I'm basically the barometer for if it should go out or not. If I can use it, literally anybody can use it. And basically what this means is now you can take the TMAC off the mill or the fabric or wood or whatever the material is, put it on the TMAC and press the big green button, as I like to call it, automatically, captures the material properties, and then it uploads to the TMAC cloud. And so anybody from your team from anywhere in the world can actually use that material basically and import it directly into any rendering engine. So it's a really, really easy tool for people like myself. which I think is going to be very helpful to kind of facilitate a lot of the, I guess, the new capabilities within rendering for brands. And I think maybe, Edmar, it might be helpful to share some of the kind of the outputs. So if I can share my screen real quick.
Yeah. And then we just, for anyone joining late, I see we have a lot of new viewers checking in, which is fantastic. Feel free to post your questions and comments in the chat. I'm going to show the short video really quick of the TMAC, so everyone who missed it in the beginning will see what the hardware we're talking about that is able to export to OpenUSD. Here we go. There it is. So how heavy is this?
Jakob, how is
yeah, well, I just 30 minutes before now, I just went from like this assembly that we're shipping. So I literally know the precise number. It's 115.32 kilograms altogether.
What is that for us Americans?
Oh, okay. I don't know.
It's multiplied by 2.2. I'm bad at math too.
It's heavy. It's heavy.
Yes, heavy.
Well, it's not that heavy. It's like 253 pounds.
Well, so compared to, I
me.
guess, that's definitely heavy to me. So actually the TMAC compared to the other kind of traditional devices on the market
is probably much lighter, right?
Well, actually the TMAC is much heavier. So all the other the other scanners in the market, there's not that many, but they basically go up to like an A7 paper size.
I see.
Very
right.
small.
You mean A4?
A4 big, it makes it unique.
Exactly.
Yeah.
So the cool thing about the TMAC is that one of the cool things, I guess, is about the TMAC is that because it's so big, then it enables people within the architecture space, the home goods space, but also manufacturers of like, basically materials that are bigger than a small swatch. It enables, I guess, to be specific again, like a leather, for instance, it's very difficult. It's impossible to basically do on a small scanner, or like a concrete.
The reason for the size is the naturality of big local contrasts, which of course there are many materials that like cannot look faithful if you have a small swatch and tile it.
And so even the training models right here, like, so if you have a very large hide of leather, then over time, if you capture enough, the really cool part is if you just take a small leather swatch down the road, then you can extrapolate out very easily based on, how leather moves essentially. And so those are some of the cool things that this kind of objective workflow enables.
And also because one more thing, because of the size and like how the perspective and point lights work and the specular separation, you can get the glossiness, sheen, and isotropy measurements. So there is just a lot of under the hood reasoning as well for the juxtaposition of cameras, lights, and the whole hardware as is.
I want to get last question to you guys. Have you guys been doing any rescanning of materials after they've experienced any wear and tear to be able to get different states of use?
So it's very funny you ask. So we're actually looking at, and we're working with several academic institutions right now to develop the version 2 TMAC, which is, we're super excited about. And what that's going to do is basically taking like things like friction, for instance, and also all the physical material properties. And it's basically a 360-degree view and representation of a material, both by encompassing optical, physical, and then what we call like multimodal mapping data. So like basically the mechanical model of a material, so like a fabric. And then once you have that, again, it's an entirely objective workflow. Things like degradation over time, we believe you can kind of extrapolate out to a certain degree. So something we're looking into heavily right now and studying.
Very cool. I put this on the screen, but on a related question, I guess, is how do you guys handle deformations of fabrics?
Yeah, so right now we're doing it basically the way everybody else is doing it currently. The TMAC V2 that is in heavy R&D right now actually captures all the material properties across not only like a local region or even like a strand, but entire region of a material like fabric.
Very cool. Another great question here. Has TMAC been used to scan translucent materials?
So in TMAC currently there's 20, let's say, photographs captured. The last one is actually when the tray that you lay the material on lights up. So you can capture alpha and translucency. Yeah. So yes. In terms of translucent materials, I mean, that question would probably need to be extended, like what is exactly used, but we use that for fabrics.
Very cool. And Stephen, I shared your screen for a second. I don't know if there was more I missed in the beginning. when you want to?
Yeah, no, there's just a whole bunch of, I guess, fabrics that we can share to, I guess, show the audience. But Edmund, maybe it's helpful to actually just show kind of like what all this is for. So when you actually look at the fabrics in detail, they're very high detail, but the whole workflow around that digital core kind of framework is, as we call it, TMAC is one piece of the kind of the larger puzzle. We think it's the critical piece because we think that the future is entirely dependent on materials, because what is basically our physical world, if not just talking about materials, materials are everything. And so if I can share my screen real quick, I can show, yeah, here we go.
All right, I will share that right now. Here we go.
Awesome. So I'll jump around a little bit, but basically this is kind of a use case to show what we mean by we're kind of like pushing storytelling or unlocking creativity, I guess. When you take all the digital materials from TMAC and you create all the models, then this is basically what we're building towards. So this is what we call FOEs, or future of environments. And this is one of our first FOEs that we've called Saint Germain. And so Saint Germain is an 8,500 square foot Parisian penthouse that's been entirely designed and developed inside of a computer by our team. And so all of these materials, everything down to the floor, the parquet de Versailles floor, or the paint and plaster, or obviously the furniture, every single thing is you can sell. And so every single one of those products, we've actually teamed up with the manufacturers and the retail brands. And so this enables a future, obviously, where you can actually just walk around these environments. I don't think that consumers are ready to basically like go full VR yet. I think that's definitely coming though. But even just practically speaking today, we've also developed like virtual production technology to actually go in and shoot the virtual worlds if you're shooting a product in the real world. So like with virtual DSLRs. And so this is some real, like, it's kind of like showing a bit of the capability, but the fidelity levels we're able to achieve here are, I guess, if I can go to the next page, are again, like you're going down to super high fidelity on each one of the materials.
Wow.
And then one, I guess, last thing is I can go super close into some of these details.
Stitching.
So
yeah.
This, for instance, all the way down to each individual stitch is done in a computer. And so again, when you think of kind of luxury and digital, there's been a lot of obvious luxury and digital are almost at odds with each other inherently. If you think about it just fundamentally, because if you have a digital product and everything is made to order or like handmade, well then it just becomes an issue with like configurators, for instance. And I can stop sharing my screen, but when you have a configurator, one of the things that was an issue for us was you have the configurator and you're moving over different materials, and then it looked like it was kind of like Photoshop, and it just honestly just killed our soul. We're like, we just did all this work, and then people are just going to think we just changed the color in the fabric. So we created like things like wiggle scripts. So every single product SKU actually moves a tiny little fraction of a hair here and there, and the lighting shifts a little bit, but everything down to the last stitch. So across all SKUs, it's entirely automated and it randomized every single individual stitch. So actually everything is quote unquote handmade in a computer down to the last stitch, because as you can imagine, we were talking like haute couture brands or, luxury artisanal brands. The last thing they want to do is these digital guys coming in and be like, hey, we're going to digitize all your stuff. They get very scared by that. But when we kind of like illustrate to them, like, look, we're doing the exact same thing. We take the exact same level of importance on all these details as you do. We're just doing it digitally. It kind of allows them to put their guard down and be open to going digital.
Very cool. I'd also like to talk a little about genAI, because I know that you guys are also looking in this area, as a lot of companies are. But for retail in particular, what are you what do you see as being on the roadmap for your team and genAI, and how might this kind of relate to OpenUSD and Omniverse?
It's just a topic we're very excited about. It's kind of like it's all consuming for us, the genAI piece of it. So all of this kind of infrastructure we're building out, the DigitalCore, the TMAC, and all those different things, that's all kind of like, we think it's a necessary base to enable this genAI future for retail. And so that's always been the plan for us. So what this has put us in a position to do is basically leverage this framework to actually unlock basically genAI within retail specifically. So you have really awesome tools like Midjourney, obviously DALL-E, Stable Diffusion, and a whole bunch of others. But kind of the holy grail within the retail side of things is actually integrating product and physically based product into really beautiful generated scenes or environments, both 2.5D, and then 3D eventually. But that's been an issue because it hallucinates on products. And it just, if I say, hey, I want this Louis Vuitton purse in this beautiful environment on XYZ model or something, it's just never going to give you that Louis Vuitton purse. So how do you do that? And you do it by, well, there's a whole bunch of reasons, a bunch of ways you could do it. How do you do it, and unlocking that piece, we think is the future, and that's where we spend all of our time. And so we're super excited about, in a couple months here, we're going to be unveiling a product we call Mode that effectively does just that. So it's the simplest way to put it is basically the mid-journey for brands, but there's a whole lot more kind of baked into that because it encompasses simulation technologies and a bunch of all cool stuff.
Very cool. So you said next few months?
I always say next few months, and then it typically ends up taking 2 times longer. So don't hold me to it. But yeah, we're actually, so we just brought in a huge team from a whole bunch of academic institutions, professors. So we have about 1 or 2 breakthroughs left until we're fully out. But
I love that. That's awesome. And I really recommend that everybody follow the Mode Maison LinkedIn page. That's where you can kind of keep up with the latest announcements and news. So follow them there. But let's dive into a little bit about how brands, like what kind of brands are you best fit for working with? Now, obviously, we mentioned some kind of use cases earlier, but how could companies start to work with you if they're a good fit?
Yeah, so initially everything started, we were just building for ourselves, like kind of our North Star being that platform. And then it pretty quickly turned into a bunch of brands just kind of reaching out and saying, hey, we heard this is all digital. We don't really believe it. Can you show us? And we obviously get really excited about talking about this stuff always. So we're like, absolutely. And then we jump on a call with them, and then they would say, okay, well, this would be super helpful for us. These are both furniture companies, but luxury fashion companies, just fashion companies general, all the way to automotive. And so that's kind of where we spun up this, it's the same company, but basically how we think about it internally is there's Mode Maison platform, and then there's Mode Maison Labs. So Mode Maison Labs is essentially like an independent research lab that basically develops all this technology and that we license out to companies around the world. And what again started primarily in the home goods space has very quickly turned into, actually we're doing a lot of fashion now, a lot of automotive, but all the way up even digitizing aerospace companies. Something we kind of say internally a lot is that if you can digitize Sophie, you can really digitize anything, because somehow a sofa is like maybe the hardest thing to actually digitize, just because it's so natural and there's such a whole bunch of complexities in it. And so we're working across the board. It's really industry agnostic. It's something that, Edmar, I think we might have talked about. It's, with Omniverse, it can do so much that sometimes it's almost overwhelming, but it's the things that get us so excited about, because you literally can do almost anything if you digitize a product. And so there's a lot of synergies and I think tie-ins between digitizing really any product and what that enables, and obviously Omniverse and being able to do a lot of cool things with Omniverse.
Yeah, well, Steve, let me ask you a quick follow-up on that. So, textiles and materials don't restrict themselves to industry. They span the globe. They cross markets. That's just their nature. And there's so many of them out there. So are you guys doing anything at the community level to try to reduce redundant scanning, to sort of how are you dealing with the sort of overwhelming number of materials that are out there?
So that's definitely been something that we're having to figure out right now, in full transparency. So we're being pretty smart about obviously we know which factories we're sending these devices out to, but we're also capturing all the metadata as well. So composition of fabric, for instance. And then this is also something that if you have all that data, then you can start to learn even the structure of a fabric, for instance. When it comes to not scanning a material twice, I would love to have that problem, honestly, because that means that you've scanned almost everything. We're not in a position, we're not close. As you said, there's so many fabrics out there. There's so many woods, there's an infinite amount of materials. So yeah, I don't know how to answer. I don't know if that answers it, but
I mean, currently we're like open, handed for harvesting, and we're solving this problem with just like more storage, I guess, which it hasn't became the problem yet because we need all that food for all the models. But on the other side of like the battle is us getting the devices on prem. So whenever we accomplish that, the manufacturer themselves digitize, and they know that they need to digitize only once, because then they can actually give that to all their vendors. So that's like the, I guess, two-sided approach.
And that's also the difference between, I guess, working directly with manufacturers and then brands. So we work with both. We work with everybody. It's less your point. It's actually more of an issue when you work with brands, because a lot of brands obviously use the same suppliers and manufacturers. Whereas if you're working directly with the manufacturer, you kind of know, because they wouldn't digitize it twice, or at least they haven't with us yet. Yeah.
And so we have a question in the chat about how accessible are some of the textures that you have available, in terms of, I guess, if people would like to take advantage of them. Is there an opportunity for people to license them, or are they being made available someplace?
Yeah, so that's the issue when it comes to like, I guess, a Quixel versus kind of a, materials when on the commercial side of things. It's a bit harder just because of the IP rights to be super open about this. There's definitely materials that we can open up to the public. Edmar, it'd actually be really kind of cool to see if we can offer kind of a material pack within.
That would be awesome.
Yeah,
let's do it.
That'd be sick. We're down. Like, again, as much as we can, we'd love to. We also have materials on our site that anybody can download.
Oh, great.
We scan like, I'd say, gazillions of materials. It's just so unfortunate that we're not able to release all of them. I mean, if it was up to us, we absolutely would, but we could definitely do more than none, basically, like we're doing now.
There's Zia with the awesome name already, the TMAC material pack.
TMAC with a dash, like
I love it.
Dinosaur.
Tracy McGrady.
We have kind of an unrelated question, but might be helpful to some of our startups out there who would like to maybe think about doing something similar. What was it like setting up a relationship with academia, universities?
You want to take that?
Yeah, I can take that one on. Well, for us as I would say both of us as the founders that have started from more like artistic point of view initially, it's been very interesting journey to get into academic world. But the more we dived into like how actually core technology is made, the more we kind of on our own started to like look through all the papers, etc. So we knew and we felt that like that's where the innovation is. And then we started like getting I guess from finding the relevant paper and basically bugging really the best people we could find on like the topics that we needed to solve. And yeah, we've literally just like I guess hard worked our way to get to know the people in the academic institutions. So now we're like in touch with Charles University deeply, with the Cambridge University very much, also with the Pixar team. So yeah, I mean, but I have to say that we have not started from inside. We've started from outside, and literally because of like the passion and technology we've made the connections and got into it. And now I would think that we're pretty well tied.
And I guess yeah, we write love letters, or I guess I can speak for myself. We just kind of like just annoy them enough where they're like, all right, fine, I'll take a 15-minute meeting if you just stop emailing me. And then they kind of like, I guess, learn a little bit about what we're doing, these kind of proprietary data sets we have, and then it gets interesting for them. One thing in academia that's really hard to get, obviously, is you can create, really incredible devices and there's that component, but then, the future being what we believe is our take is that the future is predicated entirely on obviously compute, but also the data, the critical data that we don't believe exists out there today. And so, whereas we've created this kind of this data flywheel, so to speak, with these TMACs as kind of like sensors, embedded sensors out in the real world, it's really interesting for academic researchers who are are really just compelled by creating the most innovative technology and breakthroughs. And so that kind of piece has enabled us to really work with some incredibly insightful people, professors, PhDs across the world.
That's awesome. Well, your strategy of love letters seem to have worked.
By the way, I haven't told you about the ones where they don't work. They're like, all right, yeah, got to get you on the FBI watch list. It doesn't work sometimes.
So actually, speaking of like groups working together, let's chat a little bit more about the DigitalCore Consortium, because this is kind of the key to standardization, right? Agreeing on standards, which is always a very kind of tricky thing to do, very complicated, and a lot of varying interests and stuff. Can you share a little bit more about the kind of what the DigitalCore Consortium is? And you mentioned it earlier, but maybe a little bit more and kind of what's in store there.
Yeah, so I'll try not to stumble my way through, which sometimes happens because it gets a little bit confusing and complex. But what kind of stuck with us initially was just kind of this fundamental question of like, just how do you define a material? And it seems like such an elementary question. It seems like it's obviously been answered, but really nobody sat down and said, actually, how do you define a material? And there's kind of a lot of analogies between that and the Human Genome Project, as crazy as that might sound. But basically, before the Human Genome Project really started, what they needed to do initially was actually just kind of basically define the sequence of strand of DNA. And then once they did that, they defined that DNA sequence. Then all these different technologies were basically enabled, and they have all these really incredible AI capabilities that they're doing. But that was kind of the core thing that needed to happen. So the DigitalCore Consortium is effectively doing the same thing, but for materials. So by defining a material holistically, and again, we kind of think about it in three ways, but on the optical side of things, so how do you define a material optically? The physical material parameters like the tension, the torsion, all those different properties. And then on the, I guess, the mechanical side. So actually, how does the material, when you stretch it, how does the material actually move and stuff like that? When you define a material holistically like that, we believe that the future basically just becomes entirely unlocked, because then we can actually start to develop devices that can capture that material in the most holistic sense. And right now, kind of the world's left with these very siloed approaches. But our question to ourselves is like, okay, what are all these biases that we kind of just baked in to not only just kind of how materials work, but what could we learn from that? And so if you capture enough data with the kind of a standardized approach to the measurements, then we think that, it's a spicy take, but you can basically unlock physics in a computer. You start to get closer. It's not just kind of assumptions, or it's not just theoretical. Basically, I guess, algorithms you're developing, you can truly make a data-driven approach. So that the consortium is effectively just how do you define a material, and then from that, what measurements should we take to unlock this future state?
And so is this basically an alliance of companies for the most part?
Yes, sorry. So it's a 501c6. So it's a nonprofit. We just kind of I guess sparked the initial kind of the thought exercise behind it. And so we are pulling together alliance, like you're saying, of companies, institutions, governments actually, because again, if you think about like friction, if that's an important material to define, important property to define material is friction. Well, that is helpful for a SOFA, but it's also really helpful for the U.S. government or the DoD, for instance, with like rocket technology, because you really, again, a material is really embedded in everything. So it's an open foundation. We'd obviously love everybody to join, and so we're actually going to have a site up in about 2 or 3 weeks.
That's great.
People can sign up.
That's awesome. So people listening and watching this are getting a sneak peek at some really fascinating things to come, and just short time away. Question from Zia actually on organic materials, bark, leaves, fish scales. I'm not sure what you're doing, Zia. But,
have we done fish scales?
I always actually wanted to lie there myself and just like make a face scan. But I mean it's gonna work, like definitely if you compare it to something like Quixel, that's where you can definitely get the leaves and barks. Fish scales now, I mean, that's like a very particular thing, because fish scales, they have a very dependent reflection that is that needs like a dense scanning, and is also gonna actually go out of kind of RGB, and you would need pretty much a spectral measurement as well. So I would say yes, yes. I mean, kind of. So bark yes, leaves yes, fish maybe.
All right. Well,
I just wanted to tack on one note to Steven's last comment, as he was talking about DoD and potentially scientific applications and materials. A lot of people don't know that Playtex, the bra manufacturer, actually made the Apollo spacesuits because their material properties were better in the bidding for that particular contract. So we have seen textiles go all over the place when it comes to use cases. Like, that's not improbable.
Yeah, that's super interesting. The type of people who are reaching out, we thought it was going to be a specific, like, we had the person in our head of like the retailer, but then it's been entirely different, which is exciting. You're like, you never know what email you're going to get, but the applications of just materials and just digitizing material in an objective way, I mean, it literally spans everything, which again can be daunting, obviously, because we need to be laser focused on, an industry. But when every industry can use a digital material, it's both daunting and exciting.
Edmar,
sorry, I was trying to, I had another screen open. I'm going to try to share my screen showing the TMAC website. We put the link a second ago, but just so everyone kind of take a look at this. So advertising the beta is just weeks away, it looks like.
Yes, next week.
The beta is going to be public within the first half of May.
Oh, okay, I'm wrong. Sorry.
Great. Okay. Well, that's right around the corner. And there's a TMAC device itself. So people can buy one of these now, right? They're shipping.
Yes, they are shipping. It'll be open to the public to purchase the device. They are right now. And when we say the beta is going live, you can actually use the software basically for free for a couple weeks to test it out on your own materials with your own kind of images, so to speak. And then if you like it, then get in touch with us and you can actually just purchase the hardware and the software together.
Very cool. That's awesome. I know our Omniverse ambassador, Christopher Scott, who's been on several times and was a great presenter over at GTC. I think he's got one he's very excited about coming his way.
One is coming his way. We're super excited to get him one because obviously he's like just an incredible guy and he's incredibly smart. So we're excited for him to have one in his hands.
That's great. Well, listen, this hour has just flown by. Before we leave, I kind of want to see if anyone here has any kind of last thoughts. I guess, but Jakob, the question for you, for developers out there, so people who want to really start to learn to leverage OpenUSD. What suggestions do you have for them to get started? How did you start digging into it from a technical perspective?
Well, I mean, we actually started exactly on par where the couple of months before the alliance has been happening. So that was a fortunate time because there's such a plenty of documentation. Yeah. So I mean, I guess as well, it's of course, let's say, expensive a lot. So I guess you need to pick your battles. You need to pick your battles on what you actually want from it, and I guess focus, because then, I mean, of course, it's overwhelming. Just as it's basically the MDL itself, incredibly vast topic within. So pick the battles and work a lot with the examples. Would be probably my pick.
Well, it's good advice. Good advice. Steven, do you have any parting words that you want to leave everyone? Because I know kind of we talked about a few different things, but at the top of it all is Mode Maison. So any last words you want to leave with people?
It's a big question. No, I mean, I guess just we're obviously really looking forward to what an entirely digitized basically PLM, or kind of like product lifecycle management enables, and the kind of the generative capabilities that will follow and that we're working on. Again, I'll love everybody to sign up for the consortium, just because, again, it's really in everybody's interest, we believe, in this kind of space. We think it's an imperative to basically extending and unlocking the future of digitization across all of commerce. And we think it's a critical piece that has to, basically, I don't think we get to the future unless that piece is kind of tackled. So.
Yeah, I mean, you made a very compelling case for that today. I think I was pretty impressed and blown away by this next step that's just coming for retail, and you guys are helping to do that. So thank you so much, both of you, for joining. Les had to leave right at the top of the hour because he had another meeting. So Les, thank you for joining us. For anyone who's interested in Inception, just search for NVIDIA Inception. You'll find a link for it right away, or just reach out to us in Discord. We're glad to help. Everyone out there, thank you so much for tuning in. This has been a great hour. Thanks for the great comments and questions throughout the live stream. Stephen and Jakob, I'm really excited for what's coming up. There's a few things right around the corner. So we need to have you guys back on when everything's out, and then you can give us kind of a nice update if you're available to. That would be amazing.
Of course. Thank you so much, Edmar.
Thanks for having us.
It's been awesome.
Okay. Thanks, everybody. Until next time. See you later.
Bye.
Goodbye.